Hi, so welcome to my YouTube channel. So today we solve the problem of check if all bits set, right? Means the problem says that given a number and check whether every bit in the binary representation of the given number is set or not. Set means one or not. Like return true, otherwise false, which means if n is equal to 7, right? And if n is equal to 7, then his binary representation is 7, like 2 to the power 0 is equal to 1, and 2 to the power is equal to 1 is equal to 2, and 2 to the power is equal to 2 is equal to 4, then totally 7. So we have these three element, and then we just, and all are the 1 1, which means here present yes then 1, here present yes then 1, here present yes then 1, which means 3 1 1. Then we will get the this output like true, right? So the problem is very simple. The problem says that we have to check if the our n, the given n, is binary representation is 1 or not. If all 1, then return true, otherwise return false. You can see 8 is 1 triple 0, that is comes 0, so it is the false, right? So that is the problem. So in that problem, without any thinking and without any the like very brute force which comes in your mind, like traverse every bit one by one. If any bit is 0, return false, like, right? If any bit is equal to 0, then return false. If n is equal to 0, return false. Check last bit using the formula is, we have to check the last bit and 1, then the last bit we can get. So if bit is 0, return false, then right shift the number, continue until number becomes 0, right? I will just write the code, and then you will understand the approach which I am saying. Like if n is equal to 0, then return false. Why? Because this is the 0, and 0 is always false. Now while n less than is equal to 0, then if n and 1 is equal to 0, then return false, right? Otherwise n is equal to the formula right shift, right? That is right shift, right? The right shift is n is equal to n right shift of 1, right? And then return true. Got it? Now here we can check it will run or not. So yes, it will run, but submitted, yes, it will submit it, but I will give you the another approach. This is completely good, and in that the time complexity is order of log n, right? Order of log n, because we traverse all bits, and space is order of 1 because there is no any spaces. The second one is I can use the formula here. What is the formula? The formula is very simple. The formula is n is equal to 2 to the power of k minus 1, right? Then n plus 1 is equal to 2 to the power of k, right? A power of 2 has only one set bit, right? Here a power of 2 has only one set bit, right? Now here the formula is very simple. The formula we can use here, to n and n plus 1 is equal to 0, right? Here I just nothing to think and nothing to do here. simply I just go and use this approach, formula approach, right? That the formula approach is, if n is equal to 0, that is the edge case, then return false, it will always, and then return n and n plus 1 equal to 0, right? You can see here, this is the second approach and this is also pass. Now we just come on the third approach. In that, the time complexity is order of n, because there is nothing to do, just use the formula, and the space is also of order of 1, right? Now come on the third approach using the power of 2 logic. The logic, power of 2 logic, I just write the code, then you will understand the logic here, right? If I will write the code, so same thing, if n is equal to 0, then return false, that is the common, and int x is equal to n plus 1, and return x and x minus 1 is equal to 0, and then compiled and check it will run or not. So yes, it will also run. So in that time is also the 1 and space is also the 1, right? So this is the third 3 approaches here, and the second approach is very shortest, very fast and elegant bit manipulation tricks. So thank you for staying till the end, and please like and subscribe my channel. Thank you so much.